Let's look at two more word problems that we can solve using ratio tables. Here we have Alex who can type 575 words in 15 minutes. And we have to figure out at the same rate how many words can she type in 18 minutes. Now let's make a ratio table. And we have number of words and number of minutes. It doesn't matter in which order you write. You can write number of minutes first or number of words first. It doesn't really matter. So then we have 575 words in 15 minutes. Again, we can find the unit rate by dividing both sides by 15 and figure out for 1 minute how many words she can type, because you want to eventually get to 18. And when we divide both sides by 15, you will notice that you will get not a very nice number. You will get 38.3 repeating, and obviously if it's a repeating decimal, you have to write it as a fraction, so you have to write it as 38 and 1/3. Is there a simpler way I could do this without actually getting into unit rates? I know that I'm already at 15 minutes and I want to get to 18 minutes, and if I had 3 more minutes, I could figure out how much 18 minutes is. And it's pretty easy to get from 15 to 3. I just need to divide by 5, and 15 minutes divided by 5 will give me 3 minutes. And if I do the same on the other side, 575 divided by 5, I don't know if you're used to doing short division, but here is how I would do it. 5 goes into 5 one time, 5 goes into 7 one time, and there is 2 left over, and 5 goes into 25 5 times. So 575 divided by 5 is 115. And now what we simply need to do, okay, 15 minutes is 575 words, 3 minutes is 115 words. What if we just added 15 plus 3? If we added 15 plus 3 on this side, then on the other side we would just add 575 plus 115. And 575 plus 115 would give you 690 words. So in 18 minutes, Alex can type, I can talk faster than I can write. Alex can type 690 words. So as you can see, there are clever ways of using ratio tables, and you can then avoid doing complicated calculations. Let's try another problem. So in this problem, we have Jay and Angel and Jay who are selling water bottles to raise money for new basketball uniforms. And Angel sold 5 water bottles for every 3 water bottles that Jay sold. So that's like a classic ratio problem where you have somebody sells for what somebody else sells. And then together they sold 160 bottles. So now we have to figure out how much does Jay sell. Okay, so let's start with making a ratio table. Again, as I said, you can solve this problem in many different ways. So we have number of bottles, and don't just write Angel and don't just write J, or don't just write bottles. It's number of bottles that Angel sold, and this is number of bottles that J sold. So we have let's see, what do we have? Angel sold 5 bottles for every 3 bottles that Jay sold, and we know together they sold 160 bottles. So it's not that the 160 goes here or the 160 goes here. It's the total that they sell. That means that we actually have to make a third column. Yep. And the third column will be for total. So we have total bottles sold, and we know that the total bottles sold is 160. So if Angel sells 5 bottles and J sells 3 bottles, then the total bottles sold is 8. Now, if they keep selling sets of 8, how many sets of 8 will they have to sell? So we can figure that out by saying, okay, 160 divided by 8 equals 20. So we know that 8 goes into 160 20 times. And we can do the same on the other side. So 3 times 20 is 60, and 5 times 20 is 100. So they are asking us how many bottles did J sell. So J sold 60 bottles. So sometimes when they give us the total, we have to make a third column. We have now seen how to use a ratio table in many different ways, and I hope that you keep practicing using a ratio table to solve word problems related to ratios and rates.